In this video, we'll be looking at method of solution of an inexact differential equation. Before I continue, I would like you to subscribe to this YouTube channel and click the notification bell to get notified for upcoming videos. Let's assume we're given an equation to be m of x, y dx plus n of x, y dy equal to 0. From the previous knowledge of exact differential equation, it will be said to be exact if our partial differential of m with respect to y is equal to the partial differential of n with respect to x. But in a case when it is not exact, that means the answers are not the same, is where we now bring in the inexact differential equation. And how do we solve that? We introduce an integrating factor. So we introduce, and let's call it u of x, y. Now, just the way we did our method of solution of an integrating factor, we use our integrating factor to multiply the given equation. And when we do so, we have it to be u of x, y, we multiply m of x, y dx plus u of x, y multiplying n of x, y dy equal to 0. Now, after doing this, we will now check if it is equal by differentiating. We differentiate the first expression, which is our left hand side, and equate it to the right hand side expression, which is dy of x, y multiplying m of x, y with respect to y equals, we have it to be dy of u multiplying with respect to dy x. Okay, from our idea of product rule, we are going to differentiate this, and following product rule, we leave the first, which is u, then dy m of x, y dy plus, now we differentiate the first and leave the second. We have it to be like this: m of x, y du x, y dy equal to, same goes here, we leave the first okay, dy n x, y. Now this is with respect to x, plus here we have it to be n x, y du x, y dy x. Okay, we can also write this in this format. We just have to remove the x, y, and then it looks like this: plus m du dy equals u dy n dy x plus n du dy x. Now let's collect like terms. We have to bring out the ones that have u together, and when we do so, we have it to be u dy m dy y minus u dy n dy x. Now it's equal to n du dy x minus m du dy y. Okay, we have dy y of UM equals di of UN. Oh, sorry, we already expanded this and we got it to be U di y minus U di x equals N di U di x minus M di U di y. Okay, from here we have our U to be common, and because U is common, we bring it out and we'll be left with di M di y minus di N di x equals N di U di x minus M di U di y. Alright, now to look for U of x, we equate what we have at the left hand side, di N di x, to what we have at the right hand side, but the one that has our differentiating with respect to x, because we are looking for the value of U of x. Okay, the next step here is to collect like terms. Here we had the left hand side, we have U, and at our right hand side we have di U, so we have to bring them together, and our di x will move to the left hand side and we'll divide both sides by N. Doing so, we have our answer to be di U over U equals 1 over N into di M di y minus di N di x, close the bracket, dx. To look for U with respect to y, we have to integrate both sides. So integrate both sides. And integrating both sides, we have our answer to be ln U equals integral of 1 over N di M di y minus di N di x dx. U then, taking exponents of both sides, will be equal to exponential integral of 1 over N of di M di y minus di N di x dx. So this is our U of x. Okay, so to find U of y, we follow the same method. We know that our U into di N di x minus di M di y equals to M di U di x. Now, in this situation, you observe that the di N di x is coming first. It's because of the minus sign there. When the minus sign opens the bracket, it changed their position. Just the way we did for U of x, we'll follow same for U of y, and we'll have it to be di U over U equals 1 over M into di N di x minus di M di y dx. Alright, you integrate both sides, and by integrating both sides, our answer will be ln U integral of 1 over M into di N di x minus di M di y dx. Hence, our U will be equal to integral 1 over M, that's exponential di N over di x minus di M di y dx. So this is our value for U of y. Hence, this is the method of solution for an inexact differential equation. Please do not forget to subscribe to this YouTube channel and hit the notification button to get notified for upcoming videos. Thanks.